Okay, guys, this part of the lesson on odd, even, or neither, we're going to take a look at some functions in the form of equations. And the first thing I'm always going to do is identify the degree of the function, and then I can narrow down the description as being odd or neither, or even or neither. So here in this example, we can see that our degree is 1, and that's an odd number. So our two choices are odd or neither. So I'm going to show you two different ways. First of all, we can actually plug in like a positive x and then the negative x and look at the outcomes. So I always like to use -1 and +1. So I'm going to plug in -1 first into my function, and -2 times -1 is +2. So this ordered pair is -1, 2. Now I'm going to plug in the positive x and see what the output is. So I'm going to plug in +1 and I get -2. So 1 comma -2. So again, now we're going to look at those outputs, and I can see that these are opposite. So this function is odd. It would be symmetrical about the origin. The next one, I'm going to first identify. I can see this is a linear function. Its degree is 1. Therefore, this is odd or neither. And so I'm just going to do this same test. I'm going to plug in -1. And then I'm going to plug in +1. And again, look at the outputs to see if they are opposite. So I have -2 times -1, that is 2, and 2 plus 3 is 5. -1 comma 5. And then this output, -2 times 1 is -2 plus 3 is 1. So I have 1 comma 1, and I can see that these are not opposite in sign. So it is not an odd function. It is neither. It is not symmetrical about the origin. Here we have a degree of 3. That is an odd number. So this is possibly an odd or neither function. And I'm going to keep my same test going. Always using parentheses to plug in my x values. So a -1 times a -1. So I have -1 times -1 times -1. That gives me a -1. So this -1 cubed is -1 times this outside negative now turns it to positive. So when x is -1, y is 1. Now let's test positive. So I'm going to have my negative from my function, using parentheses to plug in. So 1 times 1 times 1 is +1 times this negative is -1. So when x is 1, y is -1. Let's compare those outputs. They are opposite in sign, so it is odd, symmetrical about the origin, and it's not neither. Okay, now let me show you this other way that some folks like to do the test, and that's just with a function notation. And it's the same idea of plugging in a negative and positive x and seeing if you get exactly the same outcome to be even or opposite. So I'm going to do these first two. Well, let me do 5 and 6. So we are going to have f of x equals, and then we are going to plug in negative x plus 3. Oops, let me make that negative. So first of all, we know what the outcome is when x is positive. It is this. So we're going to be comparing this expression to what we get when we plug in a negative x. Now we're going to evaluate these negatives. -2 times negative x is +2x plus 3. So I'm going to box this in. So now we're not comparing single values, but we're the expression of our output. So in order for this to be odd, -2x and 2x need to be opposite. That is true. But also this term +3 and this would need to be opposite. We can see this is +3 and this is +3. They are not opposite. Therefore, that's why we say this is neither. Okay, let's do the same test for this third one here. So we have f of -x equals negative from the expression. And then we have -x plugged in, raised to the third. So again, when f of x, positive x, this is the outcome when x is positive. Now we're going to see what the outcome is when it is negative. So I have negative x times negative x times negative x, cubing negative x. That's going to give me negative x. And then I multiply by this outside negative, changes it back to positive. So I'm going to get a positive x cubed. So now I'm comparing these two outcomes instead of a single value, and we can see they are totally opposite in sign. That is why we can definitely know that this is odd. The outcomes are opposite. Okay, now let's take a look at these examples. Again, we're going to go through the same process, identifying the degree. So this is a quadratic, a degree of 2. So our two choices, this is an even number, our degree is. So the function's even or neither. So we're going to do that same test, starting with actual values. I'm going to plug in a -1, and then we'll plug in a +1. -1 squared, again using parentheses, a negative times a negative is positive. So this point is -1, 1. Now when x is +1, 1 times 1 is 1, so I get 1, 1. I'm looking at the outputs, and these are the same. So it is even and not neither. It is symmetrical about the y-axis. Let's go on to our next one. Our degree is 2, which is an even number, so our two choices, the function's even or neither. We're going to do our -1 and 1 test using parentheses when plugging in. Okay, so -1 times -1 is 1, and 1 plus 4 is 5. We have -1, 5. And now we're going to plug in +1. 1 times 1 is 1, plus 4 is 5. So that point is 1, 5. I'm checking out the outputs. They are exactly the same. Therefore, this is also even. It is symmetrical about the y-axis. Here we have an exponent of 2. That's an even number, so our choices are even or neither. And we are going to plug in the -1. And then we will plug in +1. So -1 times -1, that is -2. And then we square that and we get 4. And now here we're going to say 1 minus 1, that is 0, and 0 squared, of course, is 0. And so we get 1, 0. We can see here our outputs are totally different. They're not opposites. They're not the same. They are different. So this is not symmetrical about the y-axis, so it is neither. Okay, let's just do one of each of these for the other function notation. So again, we're going to look at when x is positive. This is the output. So now let's look at it when x is negative. Again, parentheses when plugging in. So a negative times a negative is positive. So the output when x is negative is x squared. It is the same as when x is positive. So it is even. Now let's take a look at it, what it looks like whenever it is neither even nor odd. So we can see the output for when x is positive is this. Okay, and this one's going to take us just a little bit, but that's okay. It gives us some good practice with applying exponents. So f of -x minus 1 quantity squared. So we can't just look at this. We're going to do the math. So first I'm going to take a look at this one, and you can't just square the x and square the -1. We have two x minus 1s. So we're going to distribute the x. Now we're going to distribute the -1. And then we're going to combine. So this is when x is positive. That's its outcome. Now we're going to do the same, and we have 2 negative x minus 1s. And distribute the negative x times negative x, that's positive x squared, negative x times negative 1, positive x. Now distribute the negative 1. And then combine. I'm running out of room here. Okay, so this is when, I don't have room to write that, but this is the output expression of when we plug in negative x. We can see these are not exactly the same. We have a negative 2x here and a positive 2x here.